The demo number 1 today will be about Azure VMs, and also that will be about CPU utilization and saturation. As you can see, I'm here on Azure portal and I do have a test VM which I called Boycott Demo 01, and I also opened the Azure Monitor metrics. The important part here is on this chart that we have on top, I have one metric. This is the percentage CPU. This is basically current CPU utilization. I have the same metric in two different aggregations, max and average, and I was able to collect that metric from the Azure itself, from the virtualization host itself. Additionally, on this chart below, what I have here, I do have my CPU saturation, and I do have that CPU saturation as an system processor queue length metric that was exposed from the guest operational system through a specific plugin that you need to install to your VM. That was basically exposed, and now I can see it here in Azure Monitor as well. So what I would like to do together with you on this one, I would like to show you basically how it differs, what kind of different patterns we have here, and how we can use those both basically utilization and saturation to understand how efficiently we plan the capacity of our computer source here. Let's start at the beginning. At this data point here, and each data point on both charts represents 1 minute. So on this data point here, as you can see, we have a queue length of 1, which is quite okay basically, and we have the CPU utilization around 2 or 3%. Then if we will move a bit more forward, for example to this data point, we can see that the saturation suddenly increased. It spikes to 39 items in a queue, and the utilization is still only on 20% at max. And this is actually quite okay. If you have a sudden spike, and then as you can basically hear on our example, and then at the next data point the queue length was reduced from 39 to 8, that basically means that you can process those tasks in a queue faster, but someone else is basically putting them there. Okay, so the utilization here is around 90% or more, which is okay, but again, because the queue lengths decreased, that means that we actually have a good capacity and we are able to process those tasks faster than someone is queuing them. Okay, so despite we're having 90, as I was saying, more than 90 even percent of the utilization here, it's still okay. We're still maintaining a good capacity and good performance on this one. Then if we can check, for example, the next area here, then that was literally the same picture. So at first we had a spike on saturation, which was 19, then we had a spike on the utilization, and at max we reach almost 80% of CPU utilization, but then the queue lengths went down. So again, we were able to process those tasks faster. But let's take a look at this particular data point here. Okay, so at this point the queue length was 10, and the next data point the queue length was 11. That basically means that in 1 minute we were unable to process all the tasks that were in a queue, and even one extra task appeared. And the utilization level at this time was almost 100% at max. At this point it was 83%, then it went up again to more than 90%. So this one actually, when your saturation level stays on a flat line, basically not changing, like here it was 10, then next time it was 11, that basically means that you are more or less operating at your max capacity. If I will put a bit more load, the system will be unable to keep up. And this is actually what was happening here. So if you will see here, the queue length was 15 and the utilization was around 100%. And then the next time queue length was 22 and utilization stays again almost at 100%. The next time the queue length was 23 and the next one even 28 and utilization stayed again around 99% at max. So if you will take a look only at the graph on top, what you will see that actually 3 times, okay, this is the first one, this is the second one, and this is the third one, 3 times you had the utilization almost at the top level, almost at 100%. But technically, in the first case, that was totally okay, because that was just one spike. On the second case, it was okay-ish, because as I was saying, for a short period of time here we had the same queue length over the 2 data points, but on the third time we can clearly see that if I would have a faster CPU, if I would have more cores and so on and so forth, I will be able to actually keep up with the load much better. So that shows me that if my utilization stays at 100%, but the queue length keeps increasing, that means that here I have a case of under provision for my compute resources. I hope on this example you understand why measuring only the utilization is not good enough, why you need to measure the saturation as well. And with that, let's go to the next demo.